Okay, so as a part of our revisions, we are going to consider extending further our revisions in our analytical geometry, and we've got a question that we need to focus on. That is our question from our past exam papers as a revision after our introduction and working with our topics. So given in this case, in the diagram below, the coordinates of triangle ABC are given as, so we've got the point A, the point B, the point C as per a diagram. And we're also given that P and Q are the midpoints of AB and BC respectively. Okay, so meaning to say the point P is on AB, this one, it's a midpoint. Q, which is on BC, it's also a midpoint. So these points, they are just midpoints, midpoints. All right. So what is it about this question? Okay, let's consider our question. The first part of our question was calculate the coordinates of P and Q, which are the midpoints for marks for that. Okay, so remember P and Q, we are told about these 2 points, P and Q, they represent what? The midpoints. All right, P is a midpoint, Q is also a midpoint. So meaning to say we can just calculate this from the midpoint concept, all right? This is 2.1. So let's start with P. So from the midpoint concept, remember that I told you guys you add the X values together. So it's going to be X1 plus X2 over 2 like this. Then you add the Y values together, then divide by 2. It's an average, like in between the given points, okay? So meaning to say we are going to add the X values together and we add the Y values together. So P, if we add the X values on A, because P is found on this line. So we are simply adding the X value here and the X value here. So this is -2 and this is -6. So that's -2 plus -6 like this, all right? Everything over what? Everything over 2. You do the same. On the Y values, we're going to consider -2, and here we've got a 4. So this is -2 plus a 4. All right, everything over what? Everything over 2. So no matter the way that you're going to present here, because it's an addition, when you are adding 2, it does not matter how you're going to have it, but what is important is that you are working with the X values together. All right, the X values, you are working with these ones together. Then you are also working with the Y values together. That is the most important part. Okay, so at the end, what are we going to have from our P? If we simplify this, it's going to give us a -4 in that case, okay? Or you can just put in this on our calculator so that we can see. Just put a fraction. So this is -2 plus -6. So we're going to plus, then we subtract -6 like this. So it's -6 everything over 2. This is going to give us a -4. All right, the same thing on the Y values, you do the same thing, -2 plus 4 over 2. So we are going to just use our calculator here, put a fraction. All right, so that's -2. So we're going to have -2 plus a 4, everything over a 2 like this, everything over 2. So this is going to give us a 1. So this is our point P that we are having, which is going to give us what? -4, 1. So it is the same thing on the point Q, all right? The point Q, we are simply going to do the same thing, x1 and x2 over 2, y1 plus y2 over 2. So the point Q, this time we are focusing on the line B and C. So we are focusing on these points. So the X value, this is -6, this is 8. So we're going to add the X values, -6 plus 8 over 2. Then the Y values, this is -2, this is a +2. So we are going to have -2 plus 2, all right, over a 2 like this. Okay, so that's it. We are going to have our point Q. So if you simplify -6 plus 8, that is going to be 2 over 2, which is a 1. -2 plus 2, that's a 0 over 2, which is a 0. All right, or we can just use the calculator, just like I said before. So this is going to be, put a fraction, that's -6 plus 8, all right, everything over 2, like that. Okay, so you're going to obtain a 1. The same on the y, that's -2, so you're going to have -2 plus 2 like this, everything over 2. This is going to give us a 0. So we put our point Q. So that's our point P and also our point Q. So 4 marks for that. Then they're asking us here on question 2.2, show that. To show, it's like you are proving, okay? That is to show, like you're supposed to show the steps until you get that. 2.21, PQ is parallel. This one means parallel to. Parallel to. So they're saying PQ is parallel to AC. All right, this is what you're supposed to show, that PQ is parallel to AC, PQ. There's need for us to present our point. Remember P here. So point P, we got -4, -4, 1. And our Q, we got our point Q here, which is 1, 0. All right. Our point Q, that's 1, 0, like that. Okay. So since I've written this, I'm just going to erase this part so that we can just use this space, find, or to calculate whatever that we want to calculate. All right. So this is what we want to show, or what we want to prove. Like I said, to show, it's just like you are proving something. Okay. So they are saying PQ is parallel to AC. So you're going to have PQ, which is 2.21. PQ is parallel to AC. Okay, what is it that we consider about the parallel lines? There's another question that we actually talked about. I think it was our previous exam revision, where we talked about the perpendicular lines. That one we talked about being the perpendicular of, the product of the two gradients giving us a -1. But if they are parallel, what is it that you consider? You consider the gradients being equal. The gradient of the line PQ must be equal to the gradient of the line AC if these two lines are what? If these two lines are parallel. If truly they are parallel, this is what we are supposed to have. So if it is the one that we are supposed to, then let us just calculate our gradients, because we have everything. We've got the point P, we've got the point Q. We calculated these points. All right, remember our point P here. We said this is -4, -4, 1. Okay, this was our point P, which is -4, 1. Okay, so you can calculate our gradient. Okay, so we can just say this is our first point, this is our second point. So let's calculate the gradient of PQ. So the gradient of PQ, remember our formula, the change in y over the change in x, y2 minus y1 over x2 minus x1, or you can do the other way around. Okay, so the gradient of PQ, that's the y value at the second point. The y value here is S0, that's S0 minus the y value from the first point, which is a 1, over x2, which is the x value at the second point minus the x value on the first point. So that's 1 minus 4. So you're just going to put it this way. Minus and a minus, it gives us a plus. Okay, so that will be 0 minus 1, which is -1 over 1 plus 4, which is a 5. So it's going to be -1 plus, because we said minus and a minus here, it's what? It's a plus. Or you can just use a calculator, guys, like I presented to you before. So this is the gradient of the line PQ, this one, the line PQ. And we now need the gradient of AC, this line AC. Okay, so let's find the gradient of line AC. So this is the gradient of the line AC. So we have the formula already. I'm not going to rewrite this formula already. We have the formula y2 minus y1. So on AC, this is what we have to consider now. This is point A and C. So you can consider this as your first point and this as your second point. So y2, that's the y value at the second point, which is 2, minus the y value here from our first point, which is a 4, over the x2, which is the x at the second point, which is 8, minus the x at the first point, which is a -2. So this point here, it's a -2. So that's -2 like that. Okay, so that is how you can have this question. This is a -2, 4. Okay, so you can have our points that way. Okay, so with this, we can be able to calculate our gradient. Either you're gonna use your calculator or just simplify step by step. All right, so on our calculator, this is 2 minus 4 over 8 minus 2 means plus. So it's 8 plus 2, which is going to give us -1 over 5. So as we can see, we obtained -1 over 5 here. Here obtained -1 over 5. I have got the same gradient, and this is what I was saying about the lines that are parallel. To say if the lines are parallel, they have got the same gradient. Their gradients are the same or they are equal. So meaning to say, therefore, we can conclude, therefore, that is PQ is parallel to AC. All right, since we can see that the gradient of the two are the same. All right, since the gradient of PQ is equal to the gradient of AC, which is equal to -1 over 5. Therefore, these two lines, they are parallel to each other. For a perpendicular, you consider another thing. The product of the gradients should give you a -1. But here we are talking about being what? Parallel, same gradient or equal gradients. Okay, so that is it about the proof. Then 2.2, again, it was to show that here we're just showing, you're just calculating as it is. PQ, it's half of AC. This is what you're supposed to show, that PQ is half of AC. All right, that's PQ here. It's half of AC. Actually, if these two lines are parallel, we have the part of our proportion. All right, if these two lines are parallel, it means this PQ is supposed to be half of what? Half of AC. But we are supposed to show that. All right, we are supposed to show that this is the question. We are supposed to show that. Okay, no problem. This is what you're supposed to show. That's 2.22. We are supposed to show that PQ is equal to half of AC. So what is it that we are supposed to prove here, or what is that you're supposed to show? It's simply the distance. PQ is simply the length that you're considering of PQ. AC again. So we just have to calculate our length of PQ. Remember, the length from the distance formula is just the difference that you're going to have on the x value. That is, we are going to subtract x2 or x1 minus x2, depending with the way that you want. X1 minus x2 squared plus y1 minus y2 squared. Okay, so that means talking about PQ. All right, if we consider this as our first point, this is our second point, we're going to subtract the x values together. -4 subtracts the x value there, which is 1. So it is going to be the square root of, like I said, x versus x. All right, so it's -4 minus 1. Subtract -1 like this squared plus the y values. To subtract the y values together, 1 minus what? 1 minus 0. So this is 1 minus 0 squared. So this gives us the distance of PQ, or the length of PQ. Yes, you can just use your formula, which is fine. Okay, you can just, you can just simplify direct, or you can just simplify on your calculator here, guys. Let's just put the square root of, open a bracket, -4 minus 1. So this is -4 minus 1 like this, squared, plus, open a bracket, that's 1 minus 0. 1 minus 0 is just the 1, guys. Okay, so just write 1 minus 0 squared, which is going to give us the square root of 26. So this gives us the square root of 26. All right, like I said, the length, just write units. Okay, the length is measured in what? In the specific unit. So that's why we're just writing units there. So we are supposed to prove this. We have to calculate AC. We calculated PQ. From P and Q, these 2 points, we have to do the same thing between the point A and C here. We are supposed to calculate its length and see if truly it is half, if truly PQ is half of that AC. All right, so let's calculate the length of AC. So still from our distance formula, I'm not gonna rewrite our distance formula. We already have our distance formula here. X1 minus X, we're just subtracting, right? So this is minus 2. This is 4, so you're gonna have minus 2x versus x. So it is the square root of minus 2 minus the x value here, which is 8, to the exponent of 2 like this. You do the same on the y values. You have got a 4 and a 2 in this case, all right? So this is plus 4 minus 2 squared like this, okay? Just taking from our formula as it is. So this is going to give us the length of AC. So as we can also do, we can just do the same as previous case. Gonna have the square root, open a bracket. We've got minus 2 minus 8 like this, minus 2 minus 8 squared, plus we do the same, 4 minus 2, 4 minus 2 squared like this. So this is going to give us 2 square root of 26. Okay, by just mere looking, guys, we can see that this is half of each other. Okay, this is, I mean, PQ is half of AC. Okay, if we do this way, all right, half of 2 square root of 26, because this is our AC, this one. So half of this must give us this, okay? Is that so? So let's multiply this answer here by a half, by 1/2 like this. What do you get? You get the square root of 26, which is this one that we got here. So it's truly that PQ, it's half of what? It's half of what? It's half of AC, okay? So that's it. That's it, guys. That's it. We have shown this, that PQ is half of what? It's half of AC. So this is what they just needed from you for this part. Let's see another part. Let's see. Now they're saying here, calculate 2.3, calculate to 2 decimal places the perimeter of triangle ABC. All right, we need the perimeter in this case to 2 decimal places. An instruction that you're given, meaning to say we are going to leave our answers to 2 decimal places. Okay, the perimeter of triangle ABC. This is what we have. Triangle ABC, that is from A to B to C. We are actually referring to the wall of this triangle. And let's see if we have got something that we calculated before. All right. We calculated AC. Remember, perimeter is the distance right around, right? Perimeter. So we calculated, remember here, we calculated what? AC, which is 2 square root of 26, this one. So we have this length of AC here, 2 square root of 26. And like I'm saying that the perimeter is simply the distance right around. If you're calculating the perimeter, it means you're supposed to add the distance right around the shape. So your perimeter in this case, if you consider, it's going to be AB plus BC plus CA. You have to consider all the sides combined together. All right, so we are considering, already we have the side AC, this one. We calculated AC. So our perimeter, we are going to need the side AB also. We do not have, we never calculated the side AB. So we are going to calculate the length of AB. All right, so there's a need for us to calculate that length of AB, okay? So let's calculate the length of AB aside here. All right, so the length of AB, like we saw from our distance formula, guys, the length is x1 minus x2 squared plus y1 minus y2 squared. So that means our AB is going to be the square root of x2 minus x1. All right, this is what we have, guys. We are considering the point A and the point B. So we consider x, which is minus 2 to minus 6. All right, so it's minus 2 minus 6. Okay, the 6 is carrying a negative, so it's minus minus, which becomes what? Positive. Okay, minus minus, guys, it gives us what? A positive 6. Okay, plus you do the same on the y value, 4 minus this y value, which is minus 2. So it is going to be 4 minus minus 2. So minus minus gives us what? A plus. So that's 4 plus 2, guys, okay? I think now we are used to this, okay? So this is going to give us the length of the line AB, okay, which is in this case, all right, let's just use our calculator again to simplify. This can help so that you see how the answers might be given. Yes, you can write them as decimals, it's fine. Okay, just leave them like that because already we've got this one as 2 square root of 6. Just leave it like that, okay? So this is going to be the square root of, open a bracket, minus 2 plus 6 squared. So we're going to have minus 2 plus 6, we square the bracket, plus, open the bracket. This is 4 plus 2 squared. So it's going to be 4 plus 2 squared, like this, which is going to give us 2 square root of 18. Just write it as it is, 2 square root of 18 units. Just leave it like that, okay? So we've calculated AB. We now have this length of AB. We need also, for the perimeter, we must also calculate the whole of this line, which is BC, and we never calculated this length before. We never calculated the length of BC before, so we are forced to calculate this because we need this on our perimeter. All right. So we're gonna calculate our length of BC here. So this is BC. I'm not gonna write out the formula already. We have our formula x1 minus x2. So on BC, we're gonna subtract the x values together. Minus 6 minus 8. Okay, so it's gonna be minus 6 minus 8 squared plus the y values minus 2 minus 2. All right, so you're gonna subtract the y values minus 2 minus 2 squared. Okay, so this gives us the length of BC. All right, also on your calculator, simplify this. So this is going to be the square root of, just open a bracket, that's minus 6 minus 8 squared. All right, plus, open a bracket, that's minus 2 minus 2 minus 2 minus 2 squared, which is going to give us 2 square root of 53. All right, so this is going to be 2 square root of 53 units. All right, so like I said, this is just the length, so just write the units or just leave it like that, it's fine. Okay, with the length that we have now, we managed to determine the whole of this part here from A to B, the whole of this line. We managed to determine the length, which is the length of AB, which is this one, 2 square root of 18, the length of BC, the whole of this line, BC, which is 2 square root of 3. Or maybe it's we wrote them as decimals, or whatever way that you wrote them. You now have this. All right, and the AC that we calculated, remember from that person, we calculated AC and we indicated this, so no longer important, this one. All right, so the perimeter now, we are simply going to combine everything. Perimeter is the distance right around the shape throughout, on like that. So you're gonna add 2 square root of 18. All right, plus we're gonna add 2 square root of 53. All right, we're gonna also add 2 square root of 26, like that. Okay, so this is our perimeter. So I'm just writing P for perimeter. A is for area. Okay, so this one, we're just gonna add everything on our calculator. So let us just save our calculator, add everything. So it's 2 the square root of 18, just move this arrow aside. Okay, gonna add 2 square root of 53, then move this arrow aside. Okay, plus 2 square root of 26. All right, like that. So this is going to give us 31,969 and so forth. So to 2 decimal place, as per instruction, remember you're told to 2 decimal place, this is going to give us 31,96, or like I said, 31,97, or like I said, you can fix this. Shift, you go to the setup, then fix on number 6 to 2 decimal place, you press 2. So this will give you 31,97 direct to 2 decimal place. So this is 31,97. 0.97 units. Okay, that's perimeter. This is to 2 decimal place as given as the instruction of our question in that case. Okay, so this is how you can attempt any question on analytical geometry. As you can see, the questions, they are just directly a way out that you just need to know your formulas from our basics. All right, know your formulas and answer the question the way that you are given. If you're asked to show that you are working out that part that you are given, and it must give you exactly what they told you must show. If it is to prove, it's another type of a question that you're supposed to work on to prove that. Right? You can be asked to calculate perimeter, you can be asked to calculate area, depending with the question that you're given, and also to understand about the midpoints. We talked about this, the issue of the midpoints and calculating of the distance. So we shall see more questions related to these ones so that we'll be able to have much practice as we are preparing ourselves for the exams. We must do as much practice as we can, do as much